day, invisible chemicals, things like PFAS and leftover medicines, end up in our water supply. These aren't just abstract pollutants, they're found in products we all use, like nonstick pans, waterproof jackets, and fast food wrappers. According to the Agency for Toxic Substances and Disease Registry, or ATSDR, these substances pose serious risks to health and our environment. As someone studying environmental engineering, I've learned how difficult it is to remove these pollutants once they enter our water systems. And the truth is, most of our current water treatment plants simply aren't designed to deal with them. Today, I want to walk you through 3 things: why traditional water treatment methods don't work on these chemicals, how these contaminants can harm people and ecosystems, and finally, how new technologies might offer a solution. Even if you're not a STEM major, this topic affects all of us. Water is something we rely on every single day. Let's start with how most water treatment systems work. They were built decades ago to remove things like dirt, bacteria, and nutrients, but today's water contains chemicals those systems were never designed to handle, like PFAS and leftover pharmaceutical drugs. In a 2020 review published in the Environmental Chemistry Letters, scientist Shakir Khan and his colleagues explained that PFAS and pharmaceutical compounds are resistant to conventional treatment methods. That means they can survive chemical treatment, filtration, and even biological processes meant to clear water. Some plants try more advanced treatment methods, but those can be extremely energy intensive and still not fully effective. On top of that, according to Lee and colleagues in a 2018 article in the Chemical Engineering Journal, some traditional treatment chemicals can actually turn pollutants into new toxic byproducts. So in short, even when we try to fix the problem, sometimes we can make it worse. So what happens when these chemicals make it through the treatment system? They don't just disappear. They stay in our water forever. PFAS, for example, are known as forever chemicals because they don't break down easily. That means they build up in rivers, soil, fish, and eventually us. According to the ASTDR, PFAS have already been found in the blood of nearly every American they've tested. Over time, these substances accumulate in the human body. The agency warns us that this buildup is linked to a variety of serious health issues, including cancer, immune system disorders, and developmental delays in children. And it's not just humans being affected. In their 2018 review, Lee and his team's report show that these contaminants can also harm wildlife. Fish and amphibians exposed to PFAS show a disruption in growth and reproduction cycles. When the food chain is affected, the consequences can spread across an entire ecosystem and even into the farms and fisheries that we depend on. Thankfully, science is starting to catch up. One of the most promising new methods is called electrochemical oxidation. It sounds complicated, but the idea is simple. Instead of using harsh chemicals, this method uses electricity to break down the pollutants directly. The ATSDR highlights several pilot studies showing that the electrochemical treatment is highly effective at removing PFAS and pharmaceuticals from water. It also produces fewer harmful byproducts compared to older methods, which is a major win for both safety and sustainability. Another exciting solution is nanotechnology. According to Khan and his team, scientists are using incredibly tiny materials like nano-zero-valent iron or carbon nanotubes to absorb or destroy pollutants. These nanoparticles are thousands of times smaller than a human hair, but they're powerful tools in trapping and neutralizing contaminants. And when combined with traditional filtration, they significantly boost the effectiveness of water treatment systems. As Lee and his colleagues know, these advanced technologies are still being tested on a larger scale, but the early results are very promising. To wrap up, let's remember, most of our existing water treatment systems aren't built to handle today's pollutants. PFAS, pharmaceuticals, and other emerging contaminants are slipping through and threatening our health, environment, and our future. But new technologies like electrochemical oxidation and nanotechnology are offering hope. The ATSDR, Khan, and Lee all show that with continued research and support, we can dramatically improve how clean our water is. Even if you're not in the STEM field, this issue touches your life. We all use water, we all deserve to know what's in it, and we can all support the efforts to keep it safe. So the next time you turn on the tap, remember that clean water doesn't happen by accident. It happens because people, scientists, engineers, and everyday citizens care enough to demand better.